All right, Andrzej, how is it looking?
Okay, we can start definitely. So I will stop sharing my screen and I give microphone to Wojtek.
Welcome everybody. It's my real pleasure to run this similar event as we did previously in Polish. So in order to be more accessible, we are trying to do similar thing with the additions to the team. Yet another portfolio startup joined. And we are trying to do what we did before, except that in English. We'll tell you what those guys are doing, and you'll see for yourself that it's not your usual SAS startup and the marketing and influencer solutions. They are indeed trying to change the world. Nevertheless, their attitude is more of the zebra than the unicorn. Even if they become unicorns, it will be just a byproduct of the delivery they will do. So with that, it's my true pleasure to invite Susan Kim-Chomicka as the first speaker. She'll tell us about her journey, especially what the heck is Canadian Korean person doing in Poland in the startup world? Susan, the mic is yours.
Hi, Wojtek. Hi, everyone. Well, simple answer is love, of course. Love always takes us to another country. And actually, what got me started in the startup world is love of potato chips. I'm joking, but it's kind of true in the sense that whenever I ate those potato chips, I kind of felt guilty, not just because it was adding to my waistline, but because as a person who's been passionate about the environment and about recycling all my life, as a little kid, I always sorted the bottles and took them to the bottle depot and and sorted the garbage well before it was popular to do so, and I would drive it down to those places where you could put it into the bins. As inconvenient as it was, one of the frustrating things was that things like those potato chips bags, which were multi-layered with different types of materials, it makes those chips fantastic and crispy without any preservatives, but it is the very reason why it couldn't be mechanically recycled. And that, along with the fact that post-consumer waste plastic is dirty, mixed, multi-material, multi-layered, it just that made it very expensive, and there were very few effective and economical ways to clean, sort, and effectively recycle those plastics. And so when I met Adam Handerek, who was the visionary and had spent over 10 years of his life developing a technology to chemically recycle those plastics, I was super excited. And I met him at a time where he was looking for funding to continue his research, and I invested in the further research. And then in 2018, we co-founded Handerek Technologies to bring all of those years of research and development in chemically recycling plastic waste into to an industrial scale, and to bring that technology to the world. So that's why I'm in the startup world, because of the passion for the environment and to be able to do something to help with the recycling of this plastic. So I'm just going to go a little bit as to how we do that. Basically, let me just share my screen here. From current slide. I was saying that all of those reasons are the reasons why 5 billion tons of plastic are landing in our landfills, because it's just been cheaper to use virgin crude oil. Oh, and so this is my team, by the way. We're a team of engineers and technicians. So what we do is we take all of those dirty mixed polymers, polystyrene, polypropylene, polyethylene, which makes up 75% of post-consumer plastic waste. And we process it, we shred the plastic, we sift it, we then take that shredded plastic and feed it into our reactors, which use a patented catalytic thermal process to break down those plastic molecules and convert it to a vapor, which then goes into our hydrotreatment center, which enriches the process. And then those, it hydrogenates it, isomerizes it, and then we distill it into the different liquid hydrocarbon fractions. What makes us unique is that everything is done at low pressure, at atmospheric pressure, and at low temperatures, which allow for a much lower capex, and it allows for really the highest quality of fuels that are currently produced by any of our competitors. And it's a highly efficient process. 1 kilogram of plastic produces 1 liter of fuel with very few byproducts. Well, it's like 1 to 2% char, which is like 20% of anybody else, the lowest competitor. And what does this mean? It basically means that a city of 300,000, like a city the size of Lublin, which produces approximately 13 to 15,000 tons of plastic per year, can now divert that plastic from landfills and can be recycled to 10 million liters of liquid hydrocarbons. And these fuels can then be used as feedstock to make virgin plastics, and thus closing the loop on the circular economy. Or it can also be used as a low carbon alternative fuel, as a fuel component to traditional fuels made from crude oil. And but it has significant greenhouse gas savings, and it meets the requirements of the Renewable Energy Directive of the European Union, which all fuel companies have to fulfill. We're a technology provider, so we are selling equipment and licensing the equipment, and our clients are like waste management companies, municipalities, fuel and chemical companies, manufacturers with large quantities of waste. And our goal is to install 200,000 tons of capacity in 5 years. So it's a huge market. There's over 260 million tons of plastic that ended as waste last year. And to reach a 50% recycling rate, McKinsey estimates that $15 to $20 billion of capital expenditure needs to be made annually through to 2030 in order to meet those kind of goals. And the American Chemical Council conservatively estimates 600 installations in the US alone could be supported. So where are we at? We've have over 10 years of R&D behind us. We've have a successful batch pilot process. We've been awarded 2 patents. We've done a successful batch process pilot. We are currently commissioning and testing our semi-industrial pilot and have started a 10,000 ton per year commercial plant. We've also successfully had 2 rounds of fundraising on top of $500,000 of our own capital. So, you know, we've been recognized and awarded as a startup, as a sustainable company, clean tech, and also for engineering innovation. And basically we were founded, our vision is that there's no waste, only renewable resources. And our mission is to create those technologies that will allow us to actualize this vision. So that's us in a quick summary.
So it is not only selling the technology, but I guess you can tap into all those grants by EU related to removing like waste and for example, carbon dioxide from the environment, right? Are you into this as well, or your customers?
You know, we haven't pursued that. One of the areas that we're researching now is the carbon credits that people are starting to look into, and so definitely we should be able to fulfill that. We definitely meet the requirements for the Renewable Energy Directive, which is a very important component of the fuel. So we really have two tracks. One is the one that is closer to our vision, which is to have a circular economy, have our product go back into making plastics again. And we're currently talking to several polymer companies about doing that and testing our fuel to make it back into plastic. But the other track, of course, is to meet the Renewable Energy Directive of fuel companies, because they're required to put
additives.
14% of carbon to meet the renewable energy directive of the European Union.
Thank you, Susan. I'll get back with more questions, but for the sake of time, I'll try to give a chance to others, starting with Tomasz Ciamulski, just because when we kind of rehearsed that, it turned out that the problem of shredding the multi-layer packages is not that hard if you know enough about the ultrasound and the electromagnetic waves. And Tomasz will definitely tell us more about this, and we'll get back to you, Susan,
Sure.
with more questions. Thanks a lot. Thank you. Tomasz, the mic is yours.
Thank you and hello. I work on new materials, so it's a similar context of providing environmentally friendly solutions and new businesses based on such solutions. But I want to go one step further in not only recycling what is available and polluting the environment right now, but also to create new materials. Wojtek said about ultrasounds, electromagnetism, and what all of that can have in common with new materials. My roots are in high-tech, in electronics, hardware, software systems, but to solve difficult problems in electronics, I had to learn electromagnetism. So I did PhD in that and use EM analysis for fundamental problems solving in electronics. And it appears that electromagnetism is everywhere in nature. So that transited me to multidisciplinary projects and invention of underwater connectors, which replace mechanical connections in harsh environment like oil and gas exploration in Norwegian shelves. And that can be solved through electromagnetism and contactless connectors. And then more Scandinavian context came into the game with forests, paper industry, and clean environment approach, which I think Scandinavians are leading in. And when I connected all that multidisciplinary projects, application of high-tech into different disciplines, I envisioned that it should be possible to create new materials which are in synergy with nature and use high-tech, not only to create something artificial like majority of industries have done so far, but to create materials which are in symbiosis with nature. So I apply high-tech in symbiosis with nature, and the strategy is based on cellulose fibers. It's beautiful material created, synthesized by nature with fantastic mechanical, biological, and chemical parameters. And I think that utilization of that material so far is on very, very limited level, and our experiments prove that. So I created multidisciplinary team and sharing the screen. I can show you that there is many applications. Okay, Do we see the screen now?
Yep.
Okay. The cellulose fibers have been used so far mainly in paper industry to create flat 2D sheets of papers. Last innovations maybe increase the speed and quality of paper, but it's possible to build 3D structures with many different properties based on this material, but multidisciplinary approach is needed. So getting the abundant and mostly available natural material on Earth and connecting that with a multidisciplinary approach in processing, it's possible to do quite a lot, much more than paper. And we've done multiple proof of principle, proof of concepts, some of the examples you see on the screen, how diverse applications can be based on this type of composites, but then I have to reach for electromagnetism, for ultrasounds, sometimes for infrared and fluid dynamic processes to harness the potential of nature. And the structures can be very light, but still strong. Some structures can be pressed or molded. Even simple applications like candles now are coming into the picture. You can hear on the market that plastic cups should be prohibited. But there are more interesting applications, and on the right, paper coatings are even faster for adaptation, like alternative to plastic packaging in mass scale. But my favorite application so far is the agro substrates. This is not only recycling, this is not only utilization of existing materials, but creation of something new. There is no such thing like controllable organic and biodegradable substrate which can be adjusted for cultivation of different plants, and we come into those needs, growing needs of local production and urban production, vertical farming, more green in the cities at home. So this is the quick overview of multiple applications of new fundamental technology, which we hope to turn into many products, but first we have to focus on something. So far the agro wins.
So did you actually try that on a larger scale? What are the revenue streams which might be of interest to our viewers here? And by the way, since I'm speaking now, just if you have questions to any of the panelists, please write them in chat and we'll try to collect them and then ask them of the panelists at the end of this conversation. Thank you. Tomek, sorry.
Yeah, as for new breakthroughs in technology and many applications, then if looking at the replacement of plastic packaging with paper coatings, that's huge multi-billion market. In case of agro substrates, that's more of a blue ocean, like a new market coming where there are nicely behaving substrates, but not organic, not biodegradable, and they can be used only in closed horticulture system based on wood, stone wool. With organic biodegradable substrate, we are opening up now possibilities to do seedling and planting from controllable environment to everywhere in the field. So it's food industry, it's agriculture, it's enormous market. So it only depends on the market pace of market acquisition, how much we can do in a short time.
Do you have Do you have any expressions of interest from potential customers for any of those products yet? Can you, if it is not actually
Yes,
leaving any
definitely.
secrets?
We've done some tests in places where those not biodegradable substrates are used so far. So there was immediate interest in replacement. There might be even new regulations coming which prohibit to use non-organic substrates. And others are also telling to us that, oh, we were actually looking for something like that. And we couldn't find solutions so far. So we are in the dialogue of defining details of useful products first, what size, what shape, which plant they want to cultivate, and we'll run all those tests in the next 1-2 years.
Okay, one final one on behalf of potential investors. Are you open for the next round, or are you good? How long is your runway? Do you need more money? Do you expect to get sales into your budget and cash flow? How does it look from that perspective?
This year we are good, but we have to face the capital intensive industrial solutions where we have to build industrial manufacturing, or at least the mostly crucial machines to create production lines. So definitely next year we will be scaling and looking for capital to get it into bigger industrial scale.
Thank you so much. And as previously, if you have any questions to Tomek, please ask them over chat and we'll get back to you. Thanks a lot. Now, Tomasz Zmysłowski, keeping in the spirit of the earth fighting for breath, yet another of the deep ideas which can potentially change a lot of huge industries. Tomek, the mic is yours.
Hi everyone, it's my real pleasure to talk to you about one of the most biggest problem we are facing now, which is CO2. CO2 pollution, CO2 capturing, what to do with CO2. COVID is one of the plague which allowed us to be conscious that if we will not act really, really fast in some advanced and huge challenges, one of them is CO2. We've, not only by the business, not only by the environmental protection, but our mankind is struggling at the moment to survive. If we will not act on the field of capturing and managing the CO2, in dozen years, it can be a catastrophe. Me and my team, we are working at the moment on the project which can handle the CO2, not only capture, not only storage, not only techno-economic processes for CO2, which whole world is now, as I said, struggling to work on, but we can in effective way work with CO2 and handle it, actually put it into the methanol. So we speak about innovative catalytic CO2 and H2 conversion to methanol technology. Let me tell you a bit word about me and my team. I am entrepreneurs since 1999. My team at the moment is focusing to deal with technologies which are dedicated for industry, environmental protection, lower energy consumption. That kind of technology are in our portfolio. One of them is, and the most important is CO2 CO2 capturing and conversion to methanol. The technology itself was developed by Japanese scientist, Professor Atsushi Urakawa, one of the most important scientists working previously in Institute ICIQ in Spain, at the moment in Institute TU Delft. Delft Technology University is one of the best research centers, especially for catalytic processes in the world, and Professor Urakawa is one of the key scientists there. Also, other partners, as you see, our scientific team is really advanced, and at the moment we want to make our cooperation with TU Delft, Netherlands University, as I said, even more, with more integration, and we are building now the platform of consortium for several companies which will support us in the process of building industrial installations for our technology all over the world. I will speak a bit more further about partners, but now let's talk about technology a bit. The technology, as I said briefly, is the most advanced at the moment in the world technology, which is dealing with CO2 and H2 into the methanol. What advantages we have? The conversion per pass 20 to 30% you can meet in current technologies, but with us it's 95, and this is absolutely all the time repeatable. You have methanol selectivity on the level 30-60%. We are doing this with 98%. Especially methanol yield, as you can see here, when the others are doing receiving 5 to 15%, we get 95, which is several times more effective technology than what you can meet in state of art. And catalyst efficiency, normally you've got per 1 kilogram of catalyst about 1 gram of methanol. We are doing in the best conversions, depending how we put the stream, up to 15.3 gram methanol from 1 gram of catalyst. This is absolutely the best result at the moment in the world, which give us a lot of advantages. For example, because we have our solution is one-pass solution, we speak about capex, which is even 4 times lower than current technologies of producing methanol going through syngas. This is really incredible effectiveness. So the reactor can be smaller. We are using much less pumps, much less recycling, much less cleaning of the process. So to make long story short, huge savings on capex with higher air, even up to almost 40% on the OPEX process. This is really incredible. So the solution itself is really advanced. We are only one technology in the world which can use separation of different exhaust gases which can contain impurities. No one else can do this. And everybody was thinking always about CO2 plus hydrogen from electrolysis process, and let's do methanol. But this process was not really efficient, and hydrogen itself needed to be really pure, like 4.9 pureness. So our advantage is that we can use also the gas from different sources, which so far are not used for not only methanol production, but they are simply, usually they are burning and they are going into the atmosphere with CO2 pollution. We speak about coal cooking plants, like coke oven gas, like hydrogenated gases from different streams in refineries. We can speak about gas of method decompositions of ammonia, Klaus methods. So the technology is opening a lot of doors for possible applications which so far are not possible, and not only possible, they are simply pollute a lot of CO2. We want to stop this process and use CO2 capturing this in methanol, and then our plan is to go to olefins, what means we have no pollution at all. We are really zero emission project. That's really I'm passionate with this process, you know, because we can really have great impact on the environment. And our thermodynamic model shows, which you can see at the moment on the screen, that only we can provide this process efficient way. Every other method, even if we would like to increase the temperature, the effectiveness of the process is not growing. And of course, everything what is on the higher pressure than 50 bars, the hydrogenation process of CO2 higher than 50 bar is protected by the patent protection, which is at the moment not only pending, but we received also the patents certificates for countries like Canada, United States, most of the countries in Europe, Russia, of course, countries which are in the Middle East, most of the countries in Middle East, China, Japan. So actually, yeah. Let me only tell you a bit more about our one. I know my time is limited, but one more thing about the market. Market itself is huge. It's $80 billion market, $80 billion market, which is growing with few percent yearly, and in 10 years it will be doubled. And we have signed the letters of intent and cooperation agreements with the industrial partners for the commercializations of our process. We are building now semi-industrial installation, and then in the next stage, first full industrial installation. And we've got, of course, we have non-disclosure agreements, so I can only briefly tell you the largest refinery in Europe, one of the three biggest producers of fertilizers and chemical cement producers in the world, biggest cooking plants in the world. So the possibility of commercialization is huge, and we want to make it global, solve the CO2 problem, and make really good business with you on this project. And the last sentence for this presentation is that only one installation, 50,000 tons per year, TPA, which is actually teeny installation, if we speak about methanol production, is capturing 68 million tons of CO2. You can imagine that whole Polish woods, forests, they are capturing about 100 million per year. So we are talking about really huge impact for the environment, and we want to protect it, and we want to make good business. Stay with us with this process.
Tomek, thank you very much. I will come back with questions. There are questions to you later. Just one thing to our viewers. If you think how it is possible that we are engaging in the projects which are obviously very capital intensive, our portfolio startups with some of our help are extremely efficient in getting R&D grants, and they are used for the real purpose. It's not fake, it's not just burning the money, it's just doing the R&D as it should be done with this money. And that's the proof that it can actually be done properly rather than wasted like in most the cases which we know. I'll not speak about this anymore. Thank you very much, Tomek. And with that, I would love to change subject and go into the software world with Sławek Pietrzyk. I cannot see him right now. Hopefully he's with us. Sławek, the mic is yours.
Hi, thank you very much. So let me share the screen. Okay, I will talk about the 5G mobile networks and how we can make money there, and also how we can greatly improve the technical solutions. Now, I am representing a 50+ team of engineers, researchers, managers with offices in Piaseczno near Warsaw and Łódź. And me, myself, I'm an ex-scientist with PhD done at Delft. By the way, that's a coincidence, maybe, with one of our colleagues, and with track record at the operators, but also in the academia. The team that we built includes really pioneers of the mobile industry in Poland. But most of all, myself, I am a competitive fighter, and that can constitute my first and only life. This is what I'm doing right now in my free time, but for over 30 years, I've been doing full contact karate, and with medals in both in Poland and in international level. Now, I'm mentioning this to you not just to, you know, proud myself somehow here, but to highlight that the values that you have if in sports and especially in martial arts, they are very much aligned with what we find useful in business. And that's the approach where we never give up. That's very important. We work extremely hard. We know that there is nothing else but just hard work. Of course, a bit of luck helps. We believe in discipline, and that the discipline leads us to freedom of choices. And we are courageous. We are not afraid of the other guys. And we know the art of war, also psychological art of war. So that was
let me interrupt here. Obviously the strategy of Gorin no show is known to Sławek, but he's not the only one. We didn't select our startups for this, but we do share. I'll get back to this and to the other participants here who are also in the hard fights sports. So we'll get back to this. Thank you, and please continue, Sławek.
Thanks a lot. So on the company side, the company is not just a fresh born startup. Actually, we are already on the market for over 13 years, and we started just after I completed writing a book, which was the first on the market globally, explicitly addressing OFDMA as a key technique for the future mobile systems. That book was published in the US, and from that point, I founded the company. That the first installation or implementation was a full-blown broadband radio for the Polish Ministry of Defense, for the supplier of the Polish Ministry of Defense. So it was already at the very start a very concrete deliverable of our work, and then we were sliding over the adoption curve of the 4G technology. So we went through research projects, then to implementation of software, and then selling those software. And very early in already 2012, we got engaged in R&D on 5G. Then we went through capital acquisition, and right now we are in implementation of the actual products, software functionalities for 5G, and we are entering the phase of capitalizing on this. On this way, we went through more than 13 projects funded by EU on research. And this is exactly what Wojtek indicated, that we are a good example of companies making use of those funds that are available on the research ground. We were collaborating with very, very many various institutions worldwide. Now, what's important here? The important thing is that we are facing the transition in the telecom industry. So the old good telecoms with software bound with hardware, with networks bound or based on large network sites, is transforming, especially in the radio access part that we do specialize in. It is transforming into a number of very low power, very low cost, small and numerous devices that can provide connectivity on the radio part, and software running on edge servers very nearby those access points that we are actually implementing. So this is the software, which is the functionality. This is where you have the heart of the whole system. Now, the future will be very much dependent on the localization, and that is an obvious thing known for the radio people. But now we should expect that this localization is of a bit different type. Namely, the times where the telecom infrastructure could be a separate infrastructure from the other infrastructure, they are already gone. It's too expensive. So we have to collocate the telecom infrastructure with the other kind of infrastructure. And therefore, you will have those access points, those tiny base stations all around you. Imagine that there is one base station per one phone around you. I mean, that sounds kind of ambitious, but that will be at the end of the day the truth. Now, what we deliver, what we implement, let me show the whole picture. We are implementing the software that runs on server, which serves the radio units, the radio heads. And the radio heads are serving the UEs, the terminals. You can have whatever radio units you want. There are multiple providers of those radio units worldwide. There are numerous providers of commercial off-the-shelf servers of the computing equipment. The trick is to implement software. And well, maybe not to take much of the time, software and the speciality we are having, what makes us different is that we are addressing the ultra dense networks, and nobody else is addressing this explicitly right now.
Well,
now,
actually, this brings us to an interesting point, namely, what are the promises? How do you see them? The promises of 5G. Everybody's talking about them, but if you actually have the 5G enabled phone, you don't see much of the difference. It's maybe 30% from time to time. Can you say something about this?
Exactly. Let me jump into this. So the numbers right now are, they look pretty large. I mean, they seem to be large, like the throughputs out of the 5G networks freshly deployed. But this is just a multiplication by like 3-4 times what we can expect in 4G. Now, and that happens only when we aggregate spectrum, which, as a matter of fact, is a true lie. What we are offered, what we are shown, it's a fake 5G. It's not a densely implemented 5G. The one that had those ambitious goals of 100 times throughput or 1,000 times capacity. Now, these were the requirements imposed by ITU on 5G. Now, the reason for that is that the networks are built according to the old good principle that has not changed for 30, 40 years so far, of macro networks that are unable, they don't scale if you want to densify them. Now, the need, the opportunity to get there is to truly build networks that are highly densified. Now, that's not easy, of course, because you run into issues with interference, but that's for sure our speciality. This is where we are preparing right now a patent application. This is, by the way, the topic of my PhD thesis, so the whole loop closes up here.
Yeah, way too many PhDs around, but that's how, again, we didn't select for this, it just so happened. Yet another, building on what you said before. So I've been in telecommunication, one of the fields where we could find the common language with Sławek. And it looks like what you are saying is putting you directly in the competition of the big guys, the vendor lock, the carrier grade equipment and so on. Do you consider it that way, or maybe you have some other ideas? Who is your competitor?
Well, just let me jump into, yeah.
You have a slide
that's
for
a good
there is an
comparison.
app. There is an app for this.
So the big guys, they are kind of representing the automotive industry 100 years ago. They built everything under one umbrella. But now you know what is the reality. The reality of a modern car is that there are hundreds of companies involved in building the car. And actually the car maker is a brand maker. So that's the reality of our competitors. The larger, let's say, circle indicates that the big guys. Now, they are this type of competitors. They try to do everything on their own, but it's impossible. That's exactly the reason why we will not have those terrific throughputs and capacities from 5G unless they are very expensive. One correction, Nokia already resigned and decided to leave this single RAN group and went into the Open RAN. Now, Open RAN is a bit better. These companies are the first wave of Open RAN, the prestigious first wave. Some people are saying that the second wave is the one that works. We are the second wave. But the point is that they all are, of course, doing a great job. They are opening their interfaces, allowing customers to choose what they want, to choose which hardware they want, like Mr. Tarek from Rakuten that is telling that nobody will tell me which hardware I am going to buy. So they know it, but they are not ultra dense. They are not truly software defined. And this is where we are actually addressing. We want to, and what we are doing is we are overshooting the market need. And we will do, and we will capitalize on the market from now for a while. But our actual hit is like more or less 2 years from now with the ultra dense networking.
Sławek, at the risk of meeting your wrath at Dojo, I need to cut you off at this moment because I don't want to not give a chance to say anything to someone which you'll need anyway, right? Somebody has to deliver the data to your RAN at the edges of this, and here enter Rafał Jaworowski, semi-half, and the Plastidinet.
Thank you.
Rafał, the mic is yours.
Thank you. And I joined a bit late to the call, so I wanted to say good evening or good morning to everybody on the call. Can you please like put up my my cover page maybe because I don't have slides, but I'll be.
Please start talking and I will work on the background slide.
So my name is Rafał, and I'm happy to tell you the story about a company that I'm running, which is Plastidinet in this case. And we are the team working on a high performance next generation Ethernet solution. And but I'll start with something different, with with maybe closer to the use case, so that I can introduce you to why we do what we're doing. So I'm pretty sure that in the last couple of weeks, when you're locked at home, you've been watching movies streamed over the Ethernet, or perhaps even played online. Maybe you even tried Google Stadia, which is kind of a game streaming online directly to your display. And I wanted to focus on the streaming part, because this is important. In the streaming, it's pixel by pixel delivered to your device, to your be it smart TV, be it handset or a laptop. And the streaming is important because it needs to have a source of the streaming, and the streaming and the source is actually a network interface. And I'm telling about this because we are building this kind of network interface, which is at the source of things like streaming movies online. But not only movies. It's just an example of the technology. So we are working on this new interface at the very bottom of the infrastructure, and we are going to build a next generation thing, which will be many times more more performant than the current solution on the market. So it will be very high performance. And the streaming example is just an example, but we are talking about the infrastructure environment. So Sławek just told you about the telecom use case and the telecom story about the upcoming 5G, and this is one of the possible consumers of our technology, which is at the bottom of the and building the backbones of high performance networks. So telecom, cloud builders, hyperscalers, all these customers and consumers of the technology that we are building are in these areas. And you might be wondering why there is a need for even more performant, more spacious solutions to the networking. And this is simply the function of the fact that there is more and more data in the world, and there will be more. And so people will be producing more data. There is a need for sending and receiving more data over network. So this is one thing why it's needed, because there will be just more data. But the other thing is that I would like to let you think about a little bit is that this data needs to be processed by servers, by cloud infrastructure. And the problem with the world and today is that the increase in compute power is not at the same pace that the data influx is. So we've been witnessing in the last couple of years, even this decade, that the so-called Moore's law essentially stopped applying. So the dynamics of the growth for the computer power is not exponential anymore. So we will not be able fundamentally to consume and to process all these humongous amounts of data the same way that we're doing today. So think about this, and because this is where we come from, and this is why we think that solutions that we're trying to propose are viable and important to resolve these kind of issues, because the current model is not going to work. We cannot basically process this much data anymore in the same approach. So
Sławek can send it over RAN, and we cannot deliver that to him, right?
Yeah. So there needs to be. We think there needs to be a different paradigm to this, and this can be addressed at least from two angles. One is that we would offload some operations, possibly closest to the source of the data, which is in our case is the network interface itself. So we want to offload some operations, but these are easy operations, and we can push them closer to the fiber, to basically the source of them. And the second thing that we are trying to address is to come up with a advanced and smart analytics of the traffic in real-time fashion, which is also going to happen on the network interface itself. So we are working on an intelligent way of processing the data. So really the only needed part that is required to be processed on the general purpose CPU is delivered there. But everything else, and even some metadata and whatever possible, we are going to do in an intelligent and autonomous way on the network interface itself. So this is where we're trying to improve the world, basically. I mentioned about the target and the consumers, the users of this technology that we're working for. So these are telecoms, these are the cloud builders, companies like Netflix, like Facebook, Google. They're direct competitors from other parts of the world. So the streaming example was one thing. The games, streaming of the games.
In the Polish version of this conversation, you said something about the AI used to manage the throughput of data through your device. Can you say a few words? Because it's pretty unique and this is actually enough data to do the AI, which is my pet peeve usually.
Yeah. I maybe it was not. I was referring to this a bit earlier when I was talking that we're going to process the network traffic in a smart, in an intelligent way. So that's where the AI and machine learning we're going to apply. So one of the use cases is, for example, to steer away from the traditional way of doing things in the network protocols processing, which is basically machine states based and kind of sequential processing. So we are going to apply some neural network models, come up with them and implement processing this in hardware. So it's done directly on a chip. So that's where we are targeting this. So it's kind of non-traditional way of using AI, because everybody else is using this for different purposes, like classifying pictures or other stuff. So the challenge here, just one thing, the challenge here will be that we are going to do this in real pseudo real-time fashion, because there's only this window of the current traffic ongoing. So we need to make decisions and based on this specific window. So.
Thanks a lot. And yeah, I'm not too good at managing time. We have one more speaker, but since I have some other obligation coming up, I'll do the questions to the previous panelists first. And I got a question. I do have a question for sorry. I read it from the panel. First question to Susan. What is the profitability for the waste management company exploiting your technology? Payback period, and how does it compare with current solutions, what they do with recycled plastic, and competitive solution? Susan?
Okay. So, all of that is going to depend significantly on the feedstock cost in that country and the product they're going to be producing at the end, because our solution is somewhat modular and can produce different types of product at the end. And so just to give a scenario from Poland, because obviously labor cost is going to make a difference, and regulations governing all the different things in running the company, the installation will be different country to country. But in general, if you were in Poland, then assuming that that you will be paid for feedstock in the quantity of about 55 euros per ton, the profitability will run around. It depends so much on modeling, but it's going to run around 30% return, and the payback period would be around 3 years. And you asked what is the what your question was, how does it
compare with current solutions?
Yeah. And what are they doing with the plastic now?
Yep.
So the reason why this is so attractive, actually the percentages can be much higher, but I tend to be very conservative in giving estimates. So I don't want to say it's going to be 60% when and the numbers.
And it is 59.
Yeah. So in the current market right now, there is no viable solutions for many of these plastics. So a lot of the waste management companies have to pay to get rid of it. So they're either having to pay to landfill it, or pay to incineration company to incinerate it, or export it somewhere. And on average, you're paying anywhere from 60 euros per ton in Poland. Now it's actually closer to 100, 60 to 100 euros per ton, and can be as much as 200 euros per ton. Some industrial installations are paying even more than that. And so conservatively estimating 50, so there are no real solutions. Yeah,
you got a competitive solution.
Yeah,
there are no solutions.
Yeah, there are, you can have incineration plants, you can have landfilling, you can have, there are other companies like myself that are working on a waste conversion solution. Like I said, what makes us unique is the quality of fuel we produce for the capex that is used. But the reality is it's such a huge problem that everybody can be working on it, and there would still be a huge market to capture. Currently, there's probably about globally maybe 19 companies, and really we're unique in being able to deliver the quality of fuel. In fact, we had a major petrochemical company come to us and said that they had tested 19 companies around the world, and the quality of our fuel, they were really amazed and our fuel was the highest quality of anybody they had tested. So that's kind of gives you.
Thank you so much. And yeah, I have a related question. I remember speaking to Tomasz Zmysłowski that actually some competitive solution end up burning the gases he would turn into methanol, which is kind of crazy, but very similar to what you said. However, the question is, what's your capex investment required in 1-3 years?
Okay. First of all, thank you for your interesting at the moment, we are providing the first stage of the project. So we gathered our own 2.2 million euro. This is the value of the first model, the first stage. We are also in the process. We opened the process of gathering next 5.2 million euro, our own. So depending on which level you would like to participate, you would like to join us, we need from 1.2 up to 3.5 million euro. As I said, depending the stage 1 or the stage 2. Both stages open between us the possibility for the full commercialization. But better is, of course, to do the both steps.
So the bigger plan, essentially, that's what it is about, right? They're testing a smaller scale to avoid the unnecessary risks, and then go higher, and then actually you can build your own factory if you have enough capex, right?
This will be the first plant, the first installation, fully commercialized, fully industrial. We will produce methanol. So our whole world is open. Then we can gather next rounds and build the installations all over the world. This is our goal.
Thank you very much. And last but not least, this time he was the first one before Marcin Szary of Secfense, and he'll tell you how he can secure your website.
Yeah, so we do operate in a quite a different space than the previous guys. We are in a cybersecurity space, and specifically in the secure user access security. And so we do a thing called user access security broker within Secfense. But I will not dig into tech details, but instead I will tell you a little story that would reveal the motivations behind why we founded the company, and so why we do what we do, and eventually how we approach the problem that we've found out that there are many companies have. And yeah, so that's the that's the story. So in 2017, there was a very significant event for the entire industry. It was when Google deployed these 85,000 of these little security keys among their employees around the globe. And by doing so, they've, I'm sorry, my slides got messy. By doing so, they've completely, do you guys can see my slides? Because apparently something got really bad. Okay, I'm back on track. So by doing so, they've completely eradicated account takeover. So there was no successful phishing attacks, no other attacks on their employees' accounts that would lead to account takeover. And as you can imagine, this is a very significant, this is a very important thing. The account takeover is in more than 80% of all security breaches around there. So that's a huge thing. And Google has learned its lesson firsthand. It was a few years prior to the deployment when they've been compromised by Chinese government as a part of a huge operation called Aurora. It was a very sophisticated attack, and Google was one of the victims of this attack. They've lost some data, we don't know how much, but they've learned the lesson. And so they've been trying to reconstruct their entire security strategy from this traditional approach when there is a very vivid perimeter. There are networks that are trusted, not trusted. So as long as you are inside, you're secure, and there's this outside threats, towards something that we today know as a zero trust security, or a thing called Beyond Corp, which in general, it means that Google have redefined this security strategy from this walled garden, this secure space, towards strongly authenticated users. And yeah, so this is where they put trust right now. And you can imagine, you could see from the zero slide with the zero that it worked. It's been 3 years since that deployment, and their accounts, employees' accounts, have not been compromised. But why so much about Google? Why am I bringing this up? It is because Google is quite an exceptional company. It has an infinite budget on cybersecurity. It has a complete control over their entire infrastructure. It even got a help from the NSA to redefine their security strategy. But most of the companies that we talk to are in a completely different position, in a completely different situation. And it's time out for me. I see.
If you can make it faster, it would be great.
Okay. And so yeah, all the companies that we were targeting had very complex infrastructure, and unlike Google, they didn't control it in a way Google did. So they've been, over the years, because they've been a mature, well-established companies, they've been acquiring different technologies from various vendors, and in result, creating this very heterogeneous mess. So for them, it was really difficult to have such a unified strategy like Google did. And this is where we come with help. We help those companies replicate the strategy that Google deployed for themselves on their heterogeneous environments. And we approach the problem of deploying like strong authentication across entire organization in a completely different way that's been done before. So prior to Secfense, the organization had to upgrade every application one by one, which you can see this. It could have been a very time-consuming process, added complexity to the organization, and it was not the very best way to cover it all within the finite budget. And so how we approach that problem, and I've lost one of the major slides here, we've instead of doing this one by one, we introduced the independent layer that is span between the span on top of the organization's infrastructure and providing the services, the security services on the fly. So there is no need to touch and modify these applications. There's no vendor lock because everything is in transit, and these organizations can scale this strategy across their entire infrastructure. Why is this important? It's because cyber threats are on the rise, and due to either internal awareness or and as well as external regulations, more and more of the companies are willing to deploy two-phase multi-factor authentication strategy in global. And due to recent reports, the market is quadrupling within the next 5 years, and we hope to help this transition, to streamline this transition for these organizations. I've done it as fast as possible.
Okay, thanks, Marcin. I can't see any more questions because we are run out of time. I think it's a moment when we can just thank all our panelists or our attendees. I hope that you enjoy this webinar and stay in touch with us. Bye.